We're going to continue. These are the last two pages that we're going to work on. The first is that SAT problem that we usually do. Let me draw some lines. Really and truly, I don't have a calculator on me. Let me stretch over here and grab a calculator. Got it? All right. So it says the angle of elevation from the tip of the building shadow to the top of the building, 63 degrees. And the distance is 220 feet from that tip of the shadow to the top of the building. So they're giving you the hypotenuse. Find the height of the building to the nearest foot. Simple trig will get this taken care of. All right. So you have your right triangle. You have your hypotenuse right there. And you want to find the length of the opposite side, right? That's the side opposite the 63-degree angle. So if we're looking at opposite and hypotenuse, we're talking about a sine function. Okay? So basically, let's go ahead and write it out. The sine of 63 degrees is equal to that unknown value, x over 220. Right? And to solve this, all we do is isolate x. So we're going to multiply both sides by 220. So we have 220 times the sine of 63 equals x. All right? And that's all you put into your calculator. Now, for this particular problem, make sure you are in degree mode. That means you hit mode, you scroll down to where it has degrees and radians, make sure the cursor or the blinking light is over degrees, hit enter, and you should be good to go. I'm going to check my calculator right now to make sure it's in degree mode. It's not. It's in radian mode because we've been working in radian mode a lot. And then hit second and quit. You'll get back to that screen. And I'm going to type in 220 sine 63 and find a value. It says 196.0214. That must mean that 196 is the height to the nearest foot. Cool? All right, here's the last bit, and it's going to be long. Here's the unit circle, dudes. I'm going to show you what I am going to give you on the exam. This is what I give you. I give you 0. Oh, come on, man. I give you 360. I'm going to do my best to write this out so you can read it. I'm going to give you 2 pi. I'm going to give you the coordinate 1, 0. Now I give you this whole first quadrant, including what we have at 90. So there's 90. There's pi over 2. The coordinates here are 0 and 1. All right. It's the other things that I'm going to have trouble writing in these spaces, but that's okay. This first degree here is 30. If you want to go ahead and say 30, 45, and 60. Those are they. Let's write it in radians. Pi over 6 is what you'll see. Pi over 4 for 45, and pi over 3 for 60. What you guys hate the most are these coordinate pairs, right? But if I give you quadrant 1, you'll be able to do everything else. So I have root 3 over 2 and 1/2. By the way, when you're up here, they're just switching places. So the cosine, or the x value at 60 degrees, is 1/2. And then we have root 3 over 2. And of course, every 45-degree angle, root 2 over 2 and root 2 over 2. Right? You should already remember that cosine is the x and sine is the y. That's not given. You should be able to remember that. You don't need to write it on your unit circle unless you want to refresh your memory. I'm not going to leave that there until I get to it later on. I went too far, didn't I? Okay. Now that you see this, I want you to think of transferring it and coterminal angles, right? Coterminal. What angle in quadrant 2 has a coterminal angle of 30? Well, there's only 30 left here, so it must be this guy right here. Okay? So everything's going to be the same. It is a 5 pi over 6. It's pi over 6 short of pi. Everybody knows that 180 is pi, right? If you don't, please don't even bother taking the test. Just kidding. All right, what's 30 degrees just short of 180? That'd be 150. And the coordinate pairs would be generally the same. But what's different? What's different in quadrant 2? The x value has to be negative. So I'm going to make it bright yellow. Hopefully that'll stick out. Oh, it's a horrible color. Let's use this ugly guy instead. Let's see if that works out. Yeah, it's a little bit better. So all the x's are negative here. Just write that out. Oh, jeez, I'm having trouble. Okay. So, do you see a pattern? Do you see a pattern? This is 45 degrees shy of 180, or 45 degrees past 90. That's 135. And that would be 3 pi over 4. Because 4 pi over 4 would be 1 pi, etc., etc. And we already know it's root 2, negative root 2 over 2, and root 2 over 2. And we'll just fill in what's left with our next 60-degree angle, which is 60 degrees shy of 180, which must mean it's 120 degrees. 135 looks like a 130. I don't like it. So it would be 2 pi over 3, right? 1 pi over 3, 2 pi over 3, 3 pi over 3. Yeah, it works out just right. Now, let's talk about reflecting downward. We're 30 degrees short of 360, which is 330 degrees. We're 45 degrees short of 360, so that's 315. And then we're 60 degrees short of 360. Now we have 300. Super simple. I got a coordinate pair of 0, -1. We know that that's 270 degrees. And for our purposes, it's 3 pi over 2. Now let's start filling in the radians for these. 2 pi in terms of sixths would be 12 over 6, but it's 1 short of that, so it's 11 pi over 6. Wish I could write better. In terms of fourths, that would be 8 over 4, but it's 1 shy, so we're going to put 7 pi over 4. And then down here, we're talking about thirds. 6/3 would be 2. So we're 1 shy of that, so we're going to be 5 pi over 3. And we can reflect either from here downward or from here over, and we'll have the same idea. I forgot the coordinate pairs, didn't I? Here we go. 30 degrees or 330 degrees. The x value is positive, which is 3 pi over 2. The y values are negative, so I'm going to stick them on the outside so I have some room. Negative, negative, and negative. Now I'll start writing on the outside. 1/2 root 2 over 2 and root 3 over 2. Sorry about that 3. And fill in the rest. How easy is that? Now, the good news is, in quadrant 3, everything is negative. Both the x and y values are negative. Negative, 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 negative. And then we're just going to copy. So if I want to go this way, if I want to copy this way, I'll start with this one. If I want to copy from here, I would start here. You choose. I'm going to do it going from quadrant 2 to quadrant 3. All right, 30 degrees past 180 is 210. It is 1 pi over 6 past 6 pi over 6, so it's 7 pi over 6. 45 degrees past 180 is 225. Pardon me, which would be 5 pi over 4. And here we have 240 degrees, which would be 4 pi over 3. All right, go back to coordinate pairs. Root 3 over 2, 1/2. Root 2 over 2. Root 2 over 2. Isn't this exciting? It's been going on forever. Just what you always wanted, to listen to my voice for an entire hour. Okay. Now that we have this all finished, your unit circle is complete. This is what I want to see. If you want that extra credit, you have to understand 2 concepts. You need to understand the positives and negatives of this whole thing, and you need to understand that in your coordinate pair, cosine is your x value of this coordinate pair, of that coordinate pair, of that coordinate pair, and sine is y. So, when I start talking about positives and negatives, in which quadrant is sine positive, in which quadrant is cosine negative, etc., etc., you need to understand where they are as coordinate pairs. Last but not least, you need to understand that tangent, in this case, is equal to sine over cosine. If you know that, then you're good to go. And I just want to say that I have a class in this room I'm covering, and they're doing a great job. Not a single sound. Couldn't be prouder right now. Thanks, guys. So, in quadrant 1, everything is positive. So we're going to say sine is positive, cosine is positive, and tangent is positive. Cool. Over here, what's positive? Well, the y-coordinate is positive, so the sine is positive. And the cosine and the tangent, therefore, are negative. In quadrant 3, both the sine and cosine are negative. And if you have a negative divided by a negative, you have a positive, so that tangent is positive. Last but certainly not least, the positive is the x-coordinate, so cosine is positive, and therefore, therefore, sine and tan are negative. That's it, guys. Sorry it was so long, but you have a lot of stuff to worry about.